Hi, everybody. I'm Tyler McMullen. As mentioned, I'm our co-founder and CTO. And I've been working on this platform for about 12 years now. And as we have built this platform, what we have spent so much of our time and energy and effort trying to build is something that can simultaneously give you the maximum amount of flexibility while also giving you the maximum amount of safety that comes along with it. And so as part of building that, that's a difficult thing to do, let's say, right? So as part of building that, some unique solutions have come out of it. Some novel ways of doing things have come out of it. And there are a bunch of things that we came to realize you can really only do on Fastly. So I want to take a few minutes to talk to you about that. The things you can only do on Fastly, as well as the assurances you can only get on Fastly. So when it comes to safety, Fastly's in kind of an interesting position there. We really cannot cut corners, for a bunch of different reasons. One of which is that we are kind of the entry point for all of your users to your platforms, to your applications, to your websites, right? Which means you're putting a lot of trust in us. And so, we really can't cut corners on that. But one of the other reasons we also can't cut corners is because of the sheer scale that we work at. It's one of those things where when you actually look at the numbers, it gets a little bit scary to think about. You're like, oh, wow. So a 1 in a million event happens every second on Fastly, multiple times a second. A 1 in a billion event on our network happens thousands of times per day. That's kind of crazy, right? And so when we go about trying to build new features, new platforms, new fundamental technology for you, we kind of need to take it very seriously, right? And we do. Not only do we do very serious engineering work on this, but we also do pretty serious cutting edge research work on this. So this is a paper that came out a few years ago, something I worked on and our team worked on with some researchers at UCSD and Stanford. And this is one particular technique we were working on for being able to prove that when we ran WebAssembly, when we ran your code on our edge compute platform, that it really was safe. Being able to prove that the code that you provided us and the code that we compiled and put out onto our network were actually semantically the same or had similar semantic properties, especially when it came to safety. We've gone beyond that now at this point. This is from several years ago, to the point now where we're taking those same ideas and working with, again, UCSD, but also with Intel at this point, working on ideas for how we can actually take some of those things and move them into the hardware itself, right? So as we go about building this platform, we're doing cutting edge engineering. We're also attempting to do cutting edge research as well. So, one of the interesting things that comes out of this is that, say how to put this. One of the interesting things that comes out of this is that when we approach these problems in a specific way, sometimes we manage to solve multiple problems at once. And I think that one of the more interesting versions of this is actually best illustrated by this graph. So this is a particular event that happened to a specific customer of ours. I believe I'm allowed to say that this is New Relic. And so at this point, what was actually happening is this is them moving traffic from one platform onto Fastly's platform, right? And if you look at the time scale there, it doesn't happen very slowly. It happens pretty quickly, right? So the vast majority of this traffic actually moves within the space of a couple minutes. And you go from 1.5 million RPS up to over 4 million RPS very, very quickly. Now, that's the kind of thing that autoscaling is supposed to be able to solve this problem, right? And autoscaling as defined by core clouds is a very impressive piece of technology. But this is not actually autoscaling. So with the way that we built Fastly's platform, with the way that we built our compute platform, there is nothing that actually needs to be auto-scaled. So going from 1.5 million RPS to 4 million RPS, we're not actually sacrificing anything. We're not doing anything different than we were doing at 1.5 million RPS. We're just creating sandboxes just the same as we were at 1.5 million RPS, right? This is the kind of thing that only happens when you look at problems from a more fundamental sort of like bottoms-up sort of approach, right? We manage to find ways to solve problems in a way that is entirely unique and sometimes, again, solves additional problems along the way. You know, again, at the scale that we're working at, we're now at over 1.8 trillion requests per day. We have the capability of handling hundreds of terabits per second, and that entire time, the actual time it takes to start up one of these incredibly safe sandboxes for your users, for your individual end user, is still under 50 microseconds. To me, that's an incredibly, I'm excited about that, is what I will say. You know? So this obsession with speed that we have, like it's built into the name, of course, right? And it's been there for 12 years now. It has clearly like made its way into our collective psyche at Fastly. And so that's been there since the very beginning, right? So Simon talked a little bit about our global purging system, right? That global purging system was built 11 years ago at this point. And it's still essentially the same piece of software. We've obviously done maintenance, we've improved it, we've made, but like the underlying algorithms inside there have not really changed in 11 years. And it is still world-class. It is still the best-in-class purging system that exists out there today. And what's interesting about this to me is that we know that other folks are working on this. We know that they're trying to catch up, but we have done really, really good work trying to build the world's fastest global purging system. And the interesting thing to me is that this is still a feature that is deeply relied upon by many of our customers. It's still exciting to many of our customers. So to talk a little bit about that and possibly even more, I'd like to invite Max Stoiber from Stellate onto the stage.
Hello, everybody. Thank you for having me. At Stellate, we sell GraphQL API edge caching to our customers. GraphQL is an API technology that was invented by Facebook back in 2014. And the unique thing about GraphQL APIs is that rather than sending many network requests to different endpoints to get all the data you need for a page, you write all of your data requirements for a page in one query, and you send that query to the origin, which resolves all the data as efficiently as possible, and then sends it back to the client. Now, GraphQL has kind of taken the world by storm, and Gartner has some statistics that by 2024, 50% of enterprises are going to be using GraphQL. So if you're not using GraphQL today, you will be soon. We build edge caching for GraphQL because GraphQL, with its unique properties, means that traditional HTTP caches don't work for GraphQL APIs. And this edge caching is by now trusted by hundreds of companies in production, including household names like Puma and Priceline. Why do these companies use our API edge caching? There's really three main benefits that they get. The first one is that they can reduce their infrastructure costs by up to 40%. Now that might seem like an exaggeration, but we see this story repeated over and over and over again. If you can cache your data at the edge, it is much cheaper to serve to your users than having your origin infrastructure having to handle every single request. They never go down even during large traffic spikes. This is particularly relevant for e-commerce, for example, over Black Friday and Christmas when they have their peak season, or for news organizations that publish a viral article. During those times, that is when the business makes the most of its revenue. And you cannot go down during those times, but they're also the most intensive on your infrastructure. By us handling 90% plus of their traffic for them, they don't even have to worry about the traffic spikes. And of course, it's blazing fast. Our customers report up to 35 millisecond P95 API response times globally. That is completely bonkers. I like to make this comparison that one human blink, so me doing this once, takes 300 milliseconds. So in that time, almost 10 responses will be served from the edge to your users, no matter where your users are in the world, which is completely mind-blowing to me. If you're in e-commerce, if you're in news, if you have some public and retail data using GraphQL, I'll be at the conference all day today and tomorrow, so come find me and talk to me about it. Now, in order to build this system, we needed to use edge infrastructure that supports what we need. And actually, this wasn't possible to build for the longest time. The first thing that we needed was, as Tyler mentioned, fast purging. Because caching dynamic data needs fast purging. If I'm an e-commerce organization and I'm caching my product data at the edge, if that cached data is out of date, if it's stale, and my product has gone out of stock, I will have users trying to check out buying a product that actually they can't buy. That is a worst case scenario. And so Fastly's incredibly fast global cache purging is a necessity in order to cache dynamic data, particularly from APIs. The other thing we needed was fast edge compute. Edge caching, fundamentally, our customers pass every single one of their API requests that are critical to their business through our infrastructure, which is powered by Fastly, obviously. And so if our analysis of all these GraphQL queries and our caching takes a long time, that is a significant impact on their business and actually negates a lot of the benefits of edge caching in the first place. So we need fast and performant edge compute infrastructure. And the third piece is that GraphQL edge caching specifically needs fast edge data storage. Because with GraphQL you're encoding all of the data requirements in one query and sending that to the origin, any requests that we get that we cache might contain pieces of data that are very cacheable and other pieces of data that are not cacheable at all. For example, if you're looking at a product page in a web shop, you might be querying some product data, and everybody's looking at the same shoe. That data is super cacheable. But at the same time, you might have a sidebar or some kind of an interface that shows AI-powered recommendations that are personalized to that specific user. And suddenly, if you can only cache the entire request, you can't cache any of it because you have these personalized recommendations in it. And so what we do and what we actually recently shipped is partial query caching, where we intelligently look at how cacheable are various pieces of data in this GraphQL query, and we cache it accordingly. And so for the recommendations, we always go to the origin and fetch the personalized recommendations for that user, but the product data will be cached for everybody. And so because we had these requirements for fast purging, fast edge compute, and fast edge data storage, we chose Fastly. And not only that, but I will go as far as saying that our business wouldn't exist if Fastly didn't exist. We're a 20-person startup. We don't have the time to build all this infrastructure from scratch. Never mind, would anybody trust us to, right? If I'm a Fortune 500 company, I'm not going to go to a 20-person organization that's telling me they're running 99 edge locations around the world. That makes no sense, right? They can't. And so by us using Fastly, our business exists. Stellate only exists because of Fastly. One of the future ideas that we've thought about that hasn't technically been possible so far is when you're a cache, you have access to invalidation requests every time data changes. We know whenever your data changes. And so what if we could connect to every single one of your clients and automatically cause them to update to the latest data? So for example, if a product goes out of stock and somebody's looking at it at that moment and trying to check out, or just looking at it, they immediately get notified and they get an update that, hey, the product just went out of stock. Sorry, you can't buy this anymore. This seems really cool, but has technically been impossible because for that, you need WebSockets at the edge. And with that, I'll hand it back over to Tyler.
Thank you very much, Max. Max hit on a really interesting point there, right? He was connecting, in what he was saying there, he connected two different ideas, right? One was about purging and the importance of purging, and the other is about like real-time communication, effectively, real-time communication to end users as well. And he hit on that, and in doing that, I actually think he found a deeper truth there, which is that a global purging system is actually just a real-time communication system. At its core, it is actually just a global broadcast system. It's a one-to-many global real-time broadcast system, right? And so when we started talking about fan-out, which Max talked about as well as Simon talked about, fan-out, I'll let you in on a secret. Fan-out is built on the exact same technology that our purging system is built on, which is why it is so fast and why it is so reliable for getting all the information out to your end users extremely quickly. And the reason we're able to do that is because this technology was built in a way to be extensible, right? And the entire Fastly platform is built in that way, which is why we're able to build these interesting and like novel features on top of our existing technology, right? Building fan-out in this way has had an interesting effect, right? I think this is best summarized, or one of my favorite versions of the summarization of this is this. So PitBoss makes grills. They make connected grills that connect to your phone and say, hey, the grill has reached this temperature, your food has reached this temperature, and if any of you have used a connected grill, you probably know that if it's a few seconds too late, much less a minute too late, that is a completely useless feature, right? And so, let me tell you how many things I've burnt in my grill. So when Ryan here from PitBoss stands up and says, like, our transfer speed has been 5 to 7 times faster, that's pretty important to me, right? Like, I'm excited to see that. That means that the technology that we have built is being used in the way that, like, in a way that is actually helping end users in a significant way. Okay, so up to now I've been talking about things that exist today. And if you've heard any of my talks at Altitude before, you know that that is almost never what I do. I always talk about things that don't yet exist or only partially exist. It's pretty classic. So I want to talk a little bit about a subject that will be very exciting to some people in the room. And for me, it's exciting because I spent much of my 20s working on this particular thing. And it was actually part of what got me into programming as a child. And that is, of course, AI. So AI and the edge have an interesting relationship in that the edge is obviously like much smaller typically than a like core cloud. Core cloud, hyperscalers, massive amounts of like computers, giant warehouses, frequently placed in places where you wouldn't necessarily want them to be for latency purposes, but they're massive, right? Whereas the edge is obviously a little bit smaller, right? We have to think a little bit about efficiency and how to do this stuff like effectively, right? But I think one of the really interesting things here is that we have spent much of the last, we as an industry have spent much of the last 20 years like trying to make the web fast again, right? We have spent a lot of time figuring out like, all right, we had a technology, the internet, that was just transferring static data from one place to another. And it was very quick in the early days of the internet, relatively speaking, right? And then we developed more advanced, more dynamic applications, and the internet got slower, and we have spent much of the last 20 years trying to make it faster again. And the edge is a really big part of that. And so as we move into this new age of AI on the internet, one of the things that I think is really important is not losing that speed, that latency, those latency improvements that we have gained over the last several years. And I think the edge is in a really interesting place to be able to help with that. However, there are like interesting challenges with this, right? So when people talk about AI, they talk about actually many different types of things. And when we talk about AI as one monolith, I think it kind of misses some of the like interesting parts here. So for instance, this box represents the size of a neural network. ResNet 50, for those who are not aware of it, is an image recognition, image classification neural network, right? It's about 150 megabytes, which when you're talking about the edge is not small, right? Typically speaking, like programs that run at the edge, on Fastly as well as other places, tend to be on the like smaller side. So ResNet 50 exists, and you could actually use it today on Fastly. You could load that into a WebAssembly module. It would work today, right? However, then when we talk about AI, that can also mean things like stable diffusion. Now, stable diffusion is about 30 times the size of an image classification network. So for those who are not aware, stable diffusion is an image generation neural network, right? And it actually gets even like worse than this, or worse. If you start looking at like modern LLMs, like Llama, that's actually 15 times the size of stable diffusion. We're now up into the many gigabytes size of things. And so when we talk about AI, we're actually talking about a wide variety of different things here, like from a computing perspective. So one of the things I think is going to be important for the edge, especially in like the coming years, is thinking about this in what I describe as like a heterogeneous computing sort of way. Sorry, I'm going to get a little bit technical. But running something like ResNet 50 is not at all the same thing as running something like Llama. And where that runs also has like different characteristics, right? Running something like Llama at the very edge doesn't always make sense, right? Because of the sheer number of operations per second that is going to have to do. And so when we step back a while back and started thinking about what does AI mean for Fastly and what do our users, what do our customers actually want out of this, realize that a lot of what folks actually want are the like user experience approaches to AI, right? And so for a lot of these, this actually already works today. And in fact, if you go back to like our earliest computed edge demos, you'll see that image classification was one of the very first things we launched on there. So, but there's a lot of things you can do with AI today on Fastly. And so like one example of this is spam detection, right? Over on the left side here, you'll see just like a little snippet I wouldn't try to run that directly, but it's like very close to the actual code that you could use for this, of actually like loading up and executing a spam detection neural network, right? And so on the side here, you can see like, all right, we'll classify this as spam. You could also attempt to do a toxicity detector. If you have user-generated content coming into your site, you might want to see like, all right, what kind of comment is this? Like, is this the kind of thing I want displayed on my site? And so I could say like, all right, this is fine, this is neutral. Or maybe it's not neutral, maybe it's extremely toxic. Whatever. We can go further with that. We could say, how about image classification? Yes, that is my cat. Or what about image generation? Right? You could generate useful images potentially for your site based on what users are inputting. You could say like, hey, here's a photo that has been generated on the fly based on a user's input. This could be useful. You could also do less useful things with it, which is what I do when I play around with image generation. So one of the things you might notice is that off to the side of this, the only thing that changed each time is actually just the name of the model that we're loading there. And so one of the things that we've been spending some time on is working with Intel and a bunch of startups and a bunch of other folks as part of the WebAssembly community to help define what it means to run neural networks and AI inside of WebAssembly, or in some cases outside of WebAssembly, right? So when we're thinking about the future of AI at the edge, we're realizing some of these things are going to be run right at the very edge, right next to your user. Some of them are going to need to like fall back a little bit further, right? Because they're actually going to take multiple seconds to run anyway, just because of the way that AI works. But what is important to me, and I think what will be important to all of us going into the future, is the way that we interact with these things. Leave it to us to like keep the latency as low as it can possibly be. We really just want to provide the environment for you to work in that is as comfortable as it can be, right? And so when we're building out something like WASI-NN, which is what this like framework over here is described as, we're obviously kind of following the same thing that we always attempt to do, which is thinking a lot about compatibility. Compatibility is obviously important for a lot of different reasons, and it's obviously been important to Fastly for a long time. If you think about the core protocols of the internet, Fastly has made, on the right side of this, a lot of contributions to the vast majority of everything that is on that screen right now. So this has obviously been important to us. That is also extended into the WebAssembly world, which we are obviously using as part of our edge compute platform. So I hope all of this gives you some idea of the additional powers and possibly even just a different way of thinking about the way that we build things and the way that you can build things on top of Fastly.